This recording is going to go through how to calculate the standard deviation for the group data. Okay, so to take into account that you've tidied up the data a little bit and that you've put it into categories, you've decided on these yourself, and you're going to calculate the standard deviation. So first thing that we'll do is we'll just move this house prices in a particular county into another area. So we'll move chart into a new sheet. Okay, so now our chart comes up down here in a sheet of its own here. So our chart is up down here, taking it away from our screen there. Now just to remind ourselves what we have some data from DAFT, 50 observations. This is the original data from DAFT, not ordered or anything like that, just copied and pasted in. I'll keep the original there, just for, in case I ever need to go back to it, that I don't have to regenerate it from DAFT or anything like that. I'll just leave it alone. I copied it into a new column here, I ordered it, carried out some simple descriptive statistics on the ungrouped data. So I see the average, 248,600, the median, 249,750, and the mode, 250,000. The standard deviation here was 60,000. So you have 68% of your sample, more or less, based within one standard deviation above or below the mean. Sorry. So what you could do is you can have there equals the average minus one standard deviation and equals the average plus one standard deviation. So you can see there that about 68% of your sample being your house prices are between 188,000 and just under 310,000. Okay. Now we grouped our data, and now we're going to have a look at what more we're going to do with this grouped data here. Okay, so we're going to first calculate the average. So what we need to do, the midpoint is known as x, and the frequency is known as f. We just notate the columns there. So the first thing we need to look at is f by x. So f by x over n is your mean. So you have equals to the midpoint multiplied by the frequency, so the number of houses in that category. You've done it once, you catch the cell by the little black corner there, drag it down. You sum the total of that. This is your total house prices overall, and you know that you have a sum of 50 house prices, so your mean or your average is equal to average open bracket, I tell a lie, it is equal to this divided by this, so the sum of fx over the number of observations. Okay, so you have 252,000, we'll put that in euro, 252,000. What was your average in your ungrouped? 248,600. So slight difference there because you're looking at your midpoint here, which is what we used to calculate our average, or one of the elements we used. Our midpoint maybe not being exactly reflective of the spread of houses in each particular category. Maybe not being exactly reflective of that. Okay, so you have 250, that's your average. Now what we're going to calculate is our standard deviation. So we just go, that's fx there. Okay, so our standard deviation, the first thing we need to do is x minus x bar. And I put in x bar there, x bar is our mean. So it's also, I just put in x bar, or mean. So x minus x bar, so we have our x, which is our midpoint, minus x bar, our mean. We get this. So now I'm just going to actually put those back into normal format there. Now x minus x bar. Now, if you decide to pull and drag these values down, thinking that you will be pulling down this value here, you would be incorrect. What you've done there is you have calculated x, which is this, minus what you thought maybe was x bar because you clicked on it here, but here it'll bring in the cell below it, and here it'll bring in 2 cells below it, and here 3 cells below it. So you want to tie in the mean into your, you want to tie in this value into your equation here. So what you do there is you click on it, and this J12 here refers to the average, it refers to what you're picking up from this cell here. So you will put a $sign before the J and a $sign after the J, and then again you will click and drag all the way down to the end We'll just open our column a bit there. We will remove any kind of formatting from it. We won't put it in euro sign at the moment. We'll come back to that. So now what it has done is, because you have put the $sign before the cell letter and the $sign after the cell letter, is you have linked that. You have linked that, and it keeps going back to the euros. We'll just do this. It links that equation in, or links that mean value into your equation there when you pull and drag it down. So that's the first thing, x minus x bar. First part you need for your standard deviation formula. Now you need to take into account that some of these, as you can see, are negative. The distance from the mean to the midpoint is negative here. You're going to remove that. You're going to negate that negative value. So what you want is x minus x bar square. You're going to square all these observations. So we will say x minus x bar. Now we'll just put a bracket around it. And we'll square it there now. Now we can't format this and put it in as a superscript, but to let us know, or me know, that it is a superscript, you put this little circumflex here, this little hat. So x minus x bar, this hat here, squared. So what you do is there is equal to this, and then you apply it. It's just above the 6, so control and 6, and you get this symbol, and 2 means that you're squaring it, so you have x minus x bar squared there. And again, all you need to do is click and drag. You have those values. You don't sum it yet because you have not at this point taken into account that some columns, some categories are weighted greater than others. There's more houses in this column than this. So you will multiply this by the frequency. And again, all you need to do is drag it down there. We just give ourselves a bit more space. This is the column that you need to sum. So you have sum f by x minus x bar square. You have summed that. Again, we will give ourselves some more space there. It doesn't give us enough space to put that in. That's fine, you don't need it at the moment. So the variance, which is our element, one of our elements in our standard deviation, so that's equal to this divided by the sample size less 1, so 49, meaning nothing. This is the variance. The standard deviation then, I should actually just write that out, is equal to the square root, which is SQRT, open bracket, close bracket, and you have 63. Let's put that in. So our standard deviation for our group data, the standard deviation is 63,252. We'll just compare that with what we had previously in our ungrouped, 60,531. We are losing a little bit of strength in our interpretations by using the group data. However, the group data gives us a neater picture of what we are talking about in terms of house prices. The group data tells us straight away the most popular category is 250 to 299. The group data tells us straight away that there are a few outliers in higher prices, such as up there 350, 400,000. However, the group data isn't exactly accurate compared to the ungrouped data. You can see there are some slight differences with the mean, some slight differences with the standard deviation. So, just to recap, we're using group data here. We're using X as the representative value for for each of these columns, each of these categories here that you've created. I've put them in groups of about 50,000. You can put them in whatever categories you want in your assignment. We have, first of all, calculating our average or our mean. So we need fx, so the sum f by x. So x is the midpoint, f by the frequency. So you multiply one by the other. You have your total number of house prices. So the sum of fx over n, the number of house prices, gives you 252,000 even. Then we're going to calculate the standard deviation. So all this is for the standard deviation calculation. X minus x bar. How far does the mean deviate from each midpoint? Some of them are negative, some of them are positive. The mean is greater than the midpoint here for this category. The mean is greater than the midpoint here for this category. However, for higher categories, the mean is less than the midpoint. We're also going to take into account that there are some negatives here. If we were to add them up, they wouldn't be reflective of the total deviation around the mean. So we apply a square to that. We're going to square each of those values. So in order to do that, we have equals this observation here, K4 squared. So that is the symbol just above the 6. And we apply that to all observations. And then we take into account the fact that some categories are weighted differently to others. So we apply the frequency to that. So we have this column by the frequency. And we drag it down to the end. We sum them up. We get the variance, which is equal to the sum of f by x minus x bar squared over n minus 1. So that's over 49. We could have also clicked on that, so put in minus 1. But we'll do 49 there. The standard deviation then is the square root of that. So you have equal SQRT, open bracket, click on your cell, close bracket, square root 63,252 and 62 cent. Slightly different, as I said, from our standard deviation of our own group data. Okay.